So, the most important fact of the day is the root of any number to a certain power could be rewritten as that base to the power of a fraction that has the power on top and the root on the bottom. Okay? So you might have a power in here, you might have a power out there, it doesn't matter, it's still going to go as a numerator on your rational exponent. The root, whatever that root is, it's going to be the denominator on your rational exponent. So let me try to explain this one more time. Let's say you had, 2 to the 2/3 power. Okay? What does that really mean? That really means 2, but what type of root does it have? The denominator is the root, so that would be a 3. So that's the third root of 2, but it has a power up here. So it's really the third root of 2 squared. So 2 to the 2/3 power is really the third root of 4. Does that make sense? Okay, so we're going to use this fact that whatever root you have, whatever base you have, whatever power you have, you could rewrite it as that exact base, but with the fraction as an exponent. It's called a rational exponent. So the numerator is the power always, and the denominator is the root always. Okay? So if I had something like the fourth root of x to the 16th, and I asked you to simplify it, okay, you need to be able to rewrite it as a rational exponent term. So what would that be? It would be x to the what? As a rational exponent, a fraction as the exponent. The power goes as the numerator. The root goes as the denominator, always. So you really have x to the 16/4. What's 16 divided by 4? So your final answer is just x to the 4th. Make sense? So jumping over here, number 18, you need to rewrite it as a rational exponent. Now remember, it doesn't matter what root you have, that's going to end up being the denominator of your rational exponent. The power, whether it's on the inside or the outside, it's going to end up being the numerator on your rational exponent. Okay? So going back to number 18, rewrite that as a rational exponent. What's it going to be? X to the 2/4. And what is 2/4 reduced down to? X to the 1/2. And what is that really as a square root function, or as a radical? The square root of x. So number 18, the fourth root of x squared really simplifies down to the square root of x. Let's check out number 19. 16, first of all, 16, it could be rewritten as 4 to a certain power, or even 2 to a certain power, right? 16 could be rewritten as 2 times 2, 4 times 2, 8 times 2, 16. So it could be rewritten as 2 to the 4th instead of 16. So if you have the 6th root of 2 to the 4th, now you could rewrite it as a rational exponent, and that would become 2 to the what? 4/6. And 4/6 could be reduced down to 2/3. So you really have 2 to the 2/3. Unfortunately, there's nothing else we could do here. Changing it back to a radical, it would be what kind of root? The square root or the third root? Third root, because the denominator is always the root. And then on the inside, 2 to what power? 2 to the 2nd power, because the numerator is the power, 2 to the 2nd power, which will be the third root of 4. So your final answer here is the third root of 4 on number 19. Number 20. Again, we could split up all these terms on the inside. So you could have the third root of 8, the third root of a to the 6th, and the third root of b to the 12th. And now on each one of those, you could simplify them. What's the third root of 8? What times itself 3 times is 8? 2. And now right here, if you rewrite that as a rational exponent, that's going to be a to the what power? 6 over 3, right? And what's 6 over 3? So you really have 2a squared, because 6 over 3 is 2. And how about the third root of b to the 12th? How could you rewrite that as a rational exponent? B to the what? Yep, b to the 4th, because 12 over 3 becomes b to the 4th. So that nasty looking third root of 8, a to the 6th, b to the 12th becomes a nice beautiful 2a squared b to the 4th. Get it? How about number 22 here? How could I rewrite that as a rational exponent? Parenthesis x minus 2 to what power? It always has a power over the root. It's always the base to the power over the root. Help me out, guys. Come on. 2/4, which becomes 1/2. So if we know that x minus 2 is to the 1/2 power, how would I write my answer? Yes. There you go. The square root of x minus 2. That's your final answer for number 22. How about 25? How would you rewrite that? X to the what? Power over root. 8/4. So your final answer is x squared. About 26. Oh. How do we rewrite 26? Let's rewrite the base. X squared to what power? To the 6/4 power. Could we reduce 6/4? Becomes 3 over 2, right? So let me just erase it and rewrite it as 3 over 2. And now that I've reduced the 6/4 to 3/2, now I could do a power to a power. What would I do? Multiply 2 times 3/2. What would I get? 2 times 3/2. Yep. 2 times 3/2, the 2's would cancel, so you just end up with the answer x to the 3rd. Whoops. You guys don't have to do number 30. Because it's the same thing as 29. My bad. $28. We're going to split that third root to the numerator and to the denominator. So we're going to have the third root of 8x to the 6th over the third root of 27 y to the 12th. Now we're going to treat this like if it were two separate problems. The numerator, the third root of 8x to the 6th, I want to split it and make it the third root of 8 times the third root of x to the 6th. So what is the third root of 8? 2. And what's the third root of x to the 6th? Well, I need to rewrite that as a rational exponent. That'll be x to what power? 6/3. And what is 6/3? 2. So I really have 2x squared. Agreed? That is my numerator. So I have 2x squared as my numerator on my answer. Let's do the same for the bottom one. The bottom one, we're going to split it up and say the third root of 27 times the third root of y to the 12th. And right there, the third root of 27 is what? 3. And how am I going to rewrite the third root of y to the 12th? 12 thirds. Wow, I recorded that too. So what is 12 over 3? 4. So we really have 3y to the 4th power. And that's our denominator. So our final answer, got to take that denominator, put it up there, 3y to the 4th. There's our final answer for that original problem. Now, number 29 is particularly interesting because you cannot have a square root in the denominator. So let's check it out. Again, we're going to split the square root to be on the numerator and the denominator. Square root of 9, x to the 4th, z to the 5th. And if you split the square root to each one of those, the square root of 9, the square root of x to the 4th, and the square root of z to the 5th, the square root of 9 is 3. What's the square root of x to the 4th? X squared, because if you write it as a rational exponent, it'll become x to the 4 over 2 power. And 4 over 2 is 2. And then z to the 5th. This is where it gets interesting. You could change it to a z to the 5th to the 1/2. And then you're going to get 2.5. And then you're going to have to split the base. Or you could do the other trick of rewriting z to the 5th as z to the 4th times z. Right? Because z to the 4th times z is really z to the 5th. So you really have 3x squared z to the what? Z to the, what's the square root of z to the 4th? There you go, z to the 2nd, and the square root of z just comes down. Now, this is my numerator. This is my numerator. Let's work on the denominator. We're going to split the square root to the 25. That's easy. The answer is 5. And split the square root to z to the 7th. Now, this is where it gets a little more interesting. So we end up with a 5. And the square root of z to the 7th, we're going to rewrite it as z to the 6th times z. Because z to the 6th times z is z to the 7th. So in our denominator, we're going to end up with what? 5 z to the what? If you rewrite that as a rational exponent, it's going to be 6 over 2. So that would be a 3 right there. And then the square root of z. Now remember, this is your denominator. This is your denominator. So you still need to put the numerator over, this top one, over the denominator, which is 5 z to the 3rd square root of z. Actually, this one came out pretty nice because it's all multiplication, which means you could cancel things out. The square root of z over the square root of z disappear, and we do not have a radical in the denominator. And then we have our z squared up on top that cancels out with 2 of these 3, so there's going to be 1 z left on the bottom. So your final answer to this guy is 3x squared over 5z.